Hello there. This is Ms. Nakayama, and I I ran out of allergy medicine, so my voice is a little scratchy, and hopefully it won't be so bad on this video. But today's lesson is SS2B because part A was sequences, so part B is series. I don't really look like a B. But I want to talk about the warm-up for just a second because you had to add up these numbers and then add up these numbers. Hope you got the right answer. Of course, Delta Math will give you that right answer after you input something. But there's a legend about a famous German mathematician named Carl Friedrich Gauss, born in the late 1700s. So this is before calculators and computers, y'all. And the teacher gave him the assignment in elementary school to add up the numbers 1 to 100, thinking that it would keep the students busy for a long time. However, Gauss almost immediately gave her the answer of 50-50 because he figured out the pattern and was able to do it that quickly in his head. So I'm going to talk about that pattern. But first, a series, we're in part B, arithmetic series. A series is formed when the terms of a sequence are added. So in other words, a sequence is a bunch of numbers with commas. A series is a bunch of numbers with plus signs in between them. That's the difference between a sequence and a series. And we are going to add them. Okay. A partial sum is denoted with this symbol. We got to know this. Change color here, make it a little different. Okay. S sub n. Okay. I'm going to be using that because this is the formula. And I like to think about it. When Gauss was adding up 1 to 100, he figured out 1 and 100 was 101, and 2 and 99 was 101. So he's adding the first term and the last term, and then he figured out there were 50 terms because it was 100 divided by 2, which is how he got, and you're like, you're right, I could do that. No problem. So anyway, let's go do some examples. Remember, it's another formula. The easiest way to learn those formulas is to write them down every time that you work the problems. So example 4, because it's continuing. So it is going to be example 4, SS2B, example 4. Find the sum of each arithmetic series. So I have a pattern, okay? There is a pattern, but to use this formula right here, I have to know the first term, which I clearly know the first term. I have to know the last term. I know the last term, but I don't know how many terms there are. So we're going to go back to what we did in part A, and that formula of a sub n equals a sub 1 plus n minus 1 times d, and I'm going to go fill in what I know. For example, a sub n is the last term, so that's 100, and a sub 1 is 2, and the common difference, that, remember, is taking a term and subtracting the one that comes before it. 4 minus 2 is 2. So when I simplify, I'm going to subtract 2. 98 equals 2 times n minus 1. Then I'm going to divide by 2 and find out that n is 50. So now, to fill in my formula, S sub 50, I have the information. I know that there are n is 50, so there are 50 terms. The first term is 2. The last term is 100. And so my sum is 2,550. Okay? And I keep saying this to you. I'm going to say it to you every day like a broken record, which y'all probably don't even know what that is. Anyway, this chapter is about teaching you, if you have a formula, you fill in what you know to find what you don't know. So look at example 4b. N is 16, a sub n is 240, and d equals 8. And I got to find the sum. So find the sum of, in this case, it's going to be 16 terms. But before that, I need to know all the information, and I don't know the first term. So a sub n equals a sub n equals a sub 1 plus n minus 1 times d. The last term is 240. I don't know the first term. I know that n is 16, and d, they tell me, is 8. So 16 minus 1 is 15, and 8 times 15 is 120. Subtract 120, and a sub 1, or the first term, is 120. So now I'm going to go to my formula, S sub 16, because n was 16. First term is what we just found of 120, and the last term is 240. So when you simplify that, I hope you can put that in your calculator in one fell swoop, get the right answer is 2,880. Okay. Example 5. Find the sum of the first 46 terms of the following series to the nearest integer. Funny. Okay, so sum of the first 46 terms is S sub 46. Okay, so I have A sub 1. I know that D is equal to 3, but I do not know the last term. So I got to go use our formula, and A sub 46 is going to be the first term of 12 plus 46 minus 1 times D, which is 3. So when you simplify that, you find out that the last term of this series, of that sequence up there, is 147. I'm looking for the sum of the first 46 terms, so that's n over 2 times the first term plus the last term. So n was 46. The first term is 12, and the last term is 147. So that is a sum of 3,657. All right, last problem. Sigma notation. I don't know if y'all have seen this before, okay? But he's kind of a big deal and used a lot, okay? What you need to remember, the first value that you start at is at the bottom. This right here is called the index. The n up here is your index, and so I start at 1 and go to n. In this particular example, we start at 1 and go to 12, okay? And what I'm doing is I'm filling in k equal to 1, k equal to 2, k equal to 3, all the way to k equal to 12, and I'm adding up those numbers. So that is what that means. So you need, I don't know if y'all have known this before, but that sigma, capital sigma, means add up all those terms. How do you find those terms? You plug in these numbers, starting at the bottom, ending at the top, wherever you see the variable. So this example 6, you will have something like this, okay? And easiest is for you to recognize that that looks like a linear equation. That means this is an arithmetic sequence of numbers, okay? So to find the arithmetic sum, S sub n is n over 2 times the first term plus the last term. So I got to figure out how many terms I have. And you can either count on your fingers, 9, 10, 11, 12, 21. But I can tell you right now it's not 21 minus 9. So if you count, but it's always 21 minus 9 plus 1. So when you subtract them, you always have to add 1. So we're going to have S sub 13, which means it's going to be 13 over 2. But what is the first term? So the first term is not plugging in 1 for m. Okay, I've got to use that index. So in this case, my first term is going to be A sub 9 because that's what the first value is. So I plug 9 in, and I find out that A sub n is 51. So that's my first term. To go find my last term, A sub n, I'm going to plug in 21. So that's A sub 21. Plugging in 21 is going to give me 111. So I plug in 111, add those up, put that in my handy dandy calculator, and I get 1,053. So that's all we have for arithmetic series. I hope you found that wasn't too difficult. If you have any questions, please don't hesitate to email me or come see me. Thank you so much for watching, and y'all have a great day.